So, hello guys, I'm Collins Cheriot, a data scientist and a geospatial analyst. So, I'm a data scientist trainee at Sangiana Consultancy Services as well as a data science intern at Code Alpha. So, today I'll walk you through a linear regression model I developed to analyze the relationship between engine size and carbon dioxide emission for a automotive industry dataset that was acquired. So let's dive right into the code and see how each part contributes to building and evaluating the model. So the first step I did was importing necessary libraries. In this case, we begin by importing the essential libraries which are pandas, NumPy, matplotlib, scikit-learn's learning model. So we import pandas as PD in this case. Pandas is a library that is used for data manipulation and analysis. And then we have NumPy is used for handling large multidimensional arrays, while matplotlib is used for data visualization. Then we have the scikit-learn's linear model is used for creating and training our linear regression model. Yeah, so we run the first cell of the code. Then we now come to the next step, which will be loading and exploring the data. In this case, this is a Python code that is used for loading and exploring loading the data into the Jupyter notebook part. Jupyter is a very good platform for data scientists because it enables you to easily write and run the code and also give a visualization platform. Yeah, whereas this Python is a very good language for data scientists. So this one is a code that is used for loading the data into the Jupyter notebook. So when we run our code, you will be able to see the output. Yeah, so we load the dataset using pandas and take a first look at the data with data.head. So data.head is a Python code that helps us to look at the data. Yeah, so these are the first few rows of the code, and then these are the columns of our dataset. So we have data.shape. This reveals the dataset's dimensions. When we run it, you can see we have the dimensions of our dataset. It tells us that we have 1067 rows and 13 columns. And then we have data.describe. It's a Python code that gives us a statistical summary of our dataset. So this one is the statistical summary. You can see some of the rows we have in our dataset, and the columns. We have model year, engine size, cylinders, fuel consumption, all those. So these are the statistical summary of our dataset. Then again, as a data scientist, it's very crucial to ensure that you are working with a very clean data set. Yeah, you have to clean your data set before we are using it for analysis. So we use this Python code to actually check for any missing values to ensure that our data set is ready for analysis. And when we run it, you can see we have zero null values for all the columns. That means our data is very ready for analysis. Yes, and then the next step will be selecting and visualizing key features. So in this case, we focus on engine size and carbon dioxide emissions, which are the key features for our dataset. So we will plot a histogram to visualize the distribution of these features. But before that, let's try to see these values for engine size and carbon dioxide emissions. Yeah, so you can see this one are the first few rows of our data set or our key features. Yeah, and then when we try to check on the statistics, you can see engine size and carbon dioxide emissions. Okay, yeah, then let's try to plot the histogram. Okay, so let's plot the histogram. So we use this code for plotting a histogram visual.fuel. In this case we defined our fuel. As you can see, it was data. We created a data frame, yeah, which has engine size and carbon dioxide emissions. So this one is the data frame we created, and in this case we want to use an histogram to visualize the outputs and the input features in this data frame. So when we run our code, you can see we have our histogram that way, where we have the engine size and carbon dioxide emissions. So you can check and even see the variables. You can make the comparison between engine size and carbon dioxide emission. And then we also come to the part where you see, these histograms are plotted to visualize the distribution of the dataset. So it's very important in visualizing the distribution. And then we have to use a scatter plot again of engine size and carbon dioxide emission. So this will visualize the relationship between engine size and carbon dioxide. Let's try to see. When we use this code, it gives us this scatter plot. So this one is a scatter plot that visualizes the relationship between engine size, as you can see, and the carbon dioxide emission. Yeah, you can play around with the colors. You can give your favorite color as you want. In this case, my favorite color is green. Yeah, and that's why I use the green, but you can have as many colors as you want. We also have we now come to the machine learning part, where we split our dataset into two parts. Are we together? Yes. So the data is split into 80% for training and 20% for testing. So this separation allows us to train the model and later evaluate its performance on unseen data. And this is how we split it. Yes. So you can see we've splitted our training data. So this one is our training data. The training data will have 853 rows and 13 columns, while the testing data will have 214 rows and 13 columns, as you can see. And then we now come to training our model. We want to train our model. Yeah, we want to train our model. So we train the linear regression model using training data, of which is 80% of the total data. So we train the model outputs a coefficient, which is the slope, and the intercept, which define the line of best fit. So when we run this code, you can see the coefficient is that one and the intercept is that way. Then we now have to plot a scatter plot along with the line of best fit. So we plot the line of best fit because it visually represents the model's prediction of carbon dioxide emission based on engine size. So let's plot and see. This is the code that is used for plotting this, and you can play around with the colors. Like I said again, for my case I used green to show the scatter plot and then blue for the line of best fit. So when we run, you can see our output is that way. Our line of best fit is this way, and the output, the scatter plot, is that way. So this line of best fit visually represents the model's prediction of carbon dioxide, carbon dioxide emissions against the engine, based on the engine size. Okay, yeah, you can change. For example, let's have this one to be red. If you want it to be a red color, you can see it's getting red. Yes. If you want this one to be blue or yellow, you can also change so that you have your scatter plot in yellow color, like that one. Yeah, but you can see green will be good for this case so that it can be very clear. Yeah, we can use green and red in that case. Yeah. Yes. Then the next step will be on creating a predictive function. So we need to create a predictive function, and this is the Python code that will be used. A function is created to predict carbon dioxide emission based on engine size. We have the engine size here and the carbon dioxide emission. So we now create a function, and this is the Python code that we'll use. And explaining this code, you can see we have the input features, the intercept, and the slope that were explained up there. And the predicted values will be the input features, you multiply it by the slope, and then you add the intercept, and then you return the predicted values. Are we together? Okay, yeah. So we come to creating a predictive function. Yeah, let's run that code. Yes, and then in this case, let's have an engine size of 8, which estimates the corresponding carbon dioxide emission. So let's run it that way. You can see we have an array of that way. So that's how our machine learning algorithm works. And this is a linear regression, which is a supervised machine learning algorithm, which is used in this case. Let's try to evaluate the accuracy of the model. So we evaluate the model on the test using the R2 score, which measures how well the model predicts carbon dioxide emission. You can see we use we import the sklearn metrics, we import the R2 score, and then we define, or we define our test X and test Y data that way, and then we predict the target values for the test using the predictive function that way. Yeah, so the art score is calculated to assess the model's accuracy, and it is also expressed as a percentage to make it easier to understand. So we want to express it as percentage, and that's why we have to multiply the art2 score by 100%. So we can have that one as a markdown. Yes, then when we run this code, you can see the R2 score is 0.78. Are we together? Yeah, so you can see it's accurate. The model is very reliable because the percentage accuracy is 78.6%, which shows its reliability. So this percentage accuracy helps us understand the model's accuracy, giving us confidence in its predictive capabilities. This process is fundamental in data science, where model evaluation ensures that our predictions are reliable and actionable. Yeah, so this is how we used linear regression machine learning algorithm in in trying to predict, analyze the relationship between engine size and carbon dioxide emissions. So that's machine learning part, which is a subset of artificial intelligence, which is also part of data science. So see you in our next video. Call me Collins Cheriot, a data scientist and a geospatial analyst. Goodbye.